let's jump in. All right, so again, I'm going to be walking you through Apex and Gigastore, and then Ward's going to be taking you through live. So, as I talked about earlier, right, we kind of focus on 4 key areas: deploy, manage, solve, and optimize. I'm going to be kind of going into sort of the manage and the solve scenarios, and we can talk about optimize and deploy as interest exists. So 2 real common scenarios of how people enter into our application. The first is, I know about an application that's having a problem. And the second is, I know about a particular user that's reporting an issue, right? Which is kind of the user complaint scenario we walked through earlier. So when we come into the initial screen here, I've got the ability to enter in a search box, and I can type in a user's IP address or an application name, a VLAN, a subnet, right? Basically, it's just straight up free string searching to be able to come in here and query on just about anything that we track. Hundreds of different, what we call dimensions of the data, right? And then the resulting data sets. Or I can just straight up jump into a scenario. So if I know that I'm experiencing some application issues, I might just come in and just say, I want to look at application performance sort of from an all-up perspective, right? And as you can see, the dashboard renders, we've got location. Geolocation capability is a default aspect of all of our workflows. So location is such a key pivot point for all of our users, right? Because you want to contextually understand, if I've got an ERP issue, is it refined to or reserved to a specific set of users at 1 or 2 particular sites, or is this widespread? And suddenly you can start to operationalize this data and very quickly understand just type of scale and scope of the problem that you're dealing with.
Is that location based on a GeoIP lookup, or
is
that what if we have a large MPLS with private networking behind?
Yeah, so it's GeoIP looked up, and the user has the ability to input files from any of their IP address managers and label the locations with GPS coordinates.
Okay.
So you've got the ability to sort of manually define it, but there's also some automation behind it as well. So you come in here and you see, in my particular case, I've got a lot of green pins at the moment. Things are running pretty well overall. But in this particular scenario, and this is a legit real world scenario, this actually came from the VIAVI network. We use a product called QuoteEdge, and we were experiencing some problems with our QuoteEdge application as folks were trying to generate quotes for customers at the end of the quarter. So if I come into this product with the context of knowing that QuoteEdge is experiencing an issue, I can scroll through my worst performing applications here, and I can see, here's QuoteEdge, and I can see how it's performing. Now, the cool thing here is that you can see I've got some green periods, but I've also got some red and yellow periods. So I've clearly got some level of sort of sporadic issue happening within this application. So I'm going to click into that application. One click contextually drills me down. It grabs that application definition as a filter, and it takes me into the next step of the workflow, where I start to isolate down on just that particular application, where it's communicating to, and where it's being consumed from.
That was a 1 hour chunk that you grabbed?
Yep. Yeah. Currently, if you see it here up in the upper right corner, I'm looking at the trailing hour.
Okay.
Yep. Exactly right.
Can you adjust the level of detail from that same upper right-hand corner, like if you wanted to get into more than just an hour? Okay.
Yep. Absolutely. You can do trailing hours, trailing days, specify a particular time window. If a trouble ticket comes in, you know what happened between 12:05 and 12:15 yesterday. Absolutely. You can also set this to auto refresh, so it'll just keep running every minute, just keep refreshing, keep plotting new data on the screen, right? So very easy to operationalize this data, throw it up on a big screen, and everybody can kind of see when things start to go awry. Now, here's an interesting thing about the NPMD industry, right, as a whole. One of the things that you'll notice is that folks will put up graphs like this, and they're great graphs. Don't get me wrong. This information is fantastic, right? It's showing a bunch of aggregated pieces of information from a disparate set of data, and it's aggregating it together, and it's sort of saying, generally, here's what's happening, right? And all that red and green, it's all based on real-time baselines that are being established. Time of day, day of week baselines. So you plug the product in, and it just starts generating information about what's happening in your environment, what your level of user expectation is, and how that maps to what's happening at the moment, right? So time of day, day of week baselines, and then percentile deviation off of that. 10% above is a critical or a marginal warning, and 20% above is a critical warning. The thing is that you get into a screen like this, and for anybody who's kind of been doing NPMD analysis, kind of tier 2 network engineers, it's pretty easy to look at this and go, well, I can see where I'm having some issues. It kind of looks like Dallas and New York, and it's pretty obvious to me, right? I've got 10 servers here being represented, and literally all the traffic is 10.200 1.10. I probably have some kind of a load balancing problem happening here, right? And it's real easy to just sort of look at the screen and go, okay, so clearly this is a load balancing issue. Nice to see you guys. I'm done. I'm out, right? And that's great. But the problem is that sometimes it's not just a load balancing issue, right? Sometimes it's just the way the data is being distributed based on the different types of applications you've got or the way your servers are configured, right? It could be regions are being routed particularly to given servers. Or it might simply be that particular server's not doing the right thing. So it's not a load balancing problem necessarily. It's simply that server is hosting up content that maybe it shouldn't be always hosting up. And so, where a lot of NPMD tools kind of stop here and they say, we've given you metadata, we've given you insights, and we're done. The VIAVI solution, and where our customers really find value in what we're doing here, is that ability to kind of keep drilling down, right? So I clicked on that one particular server, and I just keep drilling down. And I apologize, the Wi-Fi here is just a little bit slow across my VPN, but you can see here, right? I've got that particular server hosted in Chicago with my user in Dubai, and I can see the application that's being run, and I can see the sporadic nature of the problems that are occurring, right? So sometimes you can't even get to this level of depth with an NPMD tool. But the problem really is that so many of the problems that you deal with in the networking environments today are sporadic issues. You don't have everybody suffering the same problem 24/7. You've got a couple users in a couple different locations that are experiencing a particular problem or a particular issue. And so when you've got that type of scenario, it is extremely hard to use isolated metadata that's highly refined, highly aggregated, highly pruned to go in and do a deep dive problem solving exercise. You really got to have the packets for that, right? And so many NPMD vendors today say packets are blasé, right? Nobody really needs to get down to that level of detail. The problem is that root cause analysis happens at that level of detail. At least it does for our customers, right? I'm seeing some folks nodding their heads in the room, so I think you probably can relate, right? So one of the great things about this portfolio is that at any point, you can right-click and say you want to get into the packets, right? You can do a straight-up trace extraction, which I'll show you later, or you can do what we call connection dynamics. You choose your data source. Which gigastore do you actually want us to go get the packets from? And it's auto-selected to be the gigastore that the metadata was produced from. It's pretty straightforward, right? That gigastore saw the events. It's the one that produced the metadata, and so it has the packets, right? And as I mentioned, capturing data to disk at 40 gig per second, storing that information to up to a 1.2 petabyte storage array, you got a lot of packets, right? But having a lot of packets is one thing. Being able to understand which packets you're interested in is the key, right? Which is why these workflows are so powerful. They literally take you from a high-level overview down to the individual client and server that you're interested in. And then you can see it ran the job here. It extracted those packets. When I click on this, I actually get a list of all the IP conversations along with socket, so port number, that was transpiring between that client and the server. Now, this is a table, and I know there's a lot of information on it. The third column's the one, that's the gold here. It's the user experience score. So we had some really, really sharp people working on this for a long time. That user experience score is designed to take literally hundreds of unique calculations that would normally be done by a Wireshark expert with a spreadsheet and scratch paper and about 6 to 8 hours of free time, and calc all those same metrics in a dependency-based model so that we can really understand what's transpiring with the user, right? So that's the key column that I key off of when I see this, red, yellow, green, right? It's a 1 to 10 scoring scale. It's proprietary, it's patent pending from VIAVI, so it's pretty unique, and it's something we just released earlier this year. So it's something we're pretty excited about. And it allows you to quickly understand, of all these conversations, right, forget about response time, forget about propagation delay, forget about fulfillment times. Are my users experiencing things better or worse than they're accustomed to, right? And are my users experiencing degraded application performance?
So is that based on per user? So is it learning based on that user's activities? Because you have some users who are VPN in, you have some users who are in an SSH, you have people that are doing web development.
Yep.
So how is it differentiating between those different users?
It's a great question. The score is literally calced at the IP socket level. So it's IP1 port, IP2 port. And then that same information is rolled up, right? And you can consume it at a higher level. And our next release coming out at the end of the summer, we're actually going to be putting that scoring information at the very top. It's what's going to color the maps, right? But first you got to plumb it in, and you've got to get it to the lowest level of granularity so that, to your point, if today I'm on VPN and I'm experiencing one level of performance, tomorrow I'm in my home office, the next day I'm in our Minneapolis facility, my experience differs vastly from one place to the next, one environment to the next. If I'm looking at a virtual desktop infrastructure versus my local laptop, that's a totally different environment. So it's at the socket level, and that socket obviously is time bounded, right? So it's very, very contextualized.
We got a couple questions from Twitter from Bruno. He was curious about how many applications out of the box does the agent work with, and how easy is it customized?
Sure. So out of the box, the Apex Gigastore portfolio literally has hundreds of different applications. If I had to pick a number, it's well north of 500 unique applications that exist on the wire that it's going to be able to analyze and troubleshoot against. Customization is very easy. We've got application discovery, which does DPI, signature analysis of the traffic, and says that's HTTP or that's TDS or that's SIP or that's skinny running on a given port. So identify it as such throughout, right? So it's auto-discovered. The user also has the ability to kind of old school manually go in and say, TCP 5002 is actually this application. I know it to be such, right? So you've got the ability to manually define it as well. Out of the box is good for about 85% of our customers. The other 15, 20% will actually run the auto-discover and then use that to further populate and round out the default list.
So have you run into customers where they're trying to do discovery of their application, say they're going into kind of a micro-segmentation type topology, and they're using this to discover how their applications are working rather than trying to sit down with their developers, but this is kind of the express route?
All the time. Okay. That use case scenario, I'm literally going to run through it in about 3 minutes, so appreciate you being a good straight man. No, it's perfect. I appreciate it. That scenario of I want to be able to change my application architecture, or I want to be able to move to the cloud, and I have to understand what dependencies exist and how users experience the app today. To your point from earlier, how do users actually authenticate to applications? It's not uncommon at all for us to go into big organizations that have these legacy applications, and you go, how does this thing work? And they go, I have no clue. The guy who knew left about 15 years ago, and we just try not to kick it too hard, and it seems to keep running, right? So that scenario of, and now I need to move this thing to the cloud, or I need to figure out how to leverage remote storage, and I got to not break it in the process. That whole migration process of the deploy strategy is a huge piece of what we do. And so I'll show you that in just a minute.
So I guess I'm trying to figure out what's the source of truth in all of this. Like we get down to the packet level, and it seems like there's a capture component, but then you also have a remote agent for testing performance in sort of synthetic traffic.
Yeah.
Right? How do you, if you're going to take multiple sources of data like that, because it sounds like there's a lot of like packet crunching going on here.
Yep.
At the actual packets, the headers, figuring out what's going on. But then you add synthetic user testing. We have application definition. Like, how do we correlate all of that? Because it's often been a challenge. Because,
Yes.
Packets are great, but they require a lot of interpretation.
Yes.
And so you're saying we get there, but there seems to be a gap to me.
There is a little bit of a gap today as on the market as a whole. Totally agree with that. And that's actually what I'm going to show you in just the very end of the presentation today.
Okay.
So you guys are fantastic. I appreciate it. You are tracking, you're paying attention, and this is all going to come together into beauty and wonderment at the very end here. So I appreciate the question. We will absolutely show you some of that. You're right, though. This does require a ton of packet crunching, right? And so that's one of the challenges is that this technology is based on an organization called Network Instruments that was founded in 1994, right? So been around for, going on 25-ish years, right? I've been in the space for 18 years. Analytics were always sort of like real rudimentary, and I talk about this journey from data, which is, here's your packets, do with them what you will, to information, which is, hey, I've layered on some baselining, I've calced some metrics for you, maybe I've rolled up all into some really defined metrics. Information is good, right? But what customers are really trying to get to is answers, right? Because folks that can read trace files, and I know we've got some Wireshark folks in the room here, folks that can actually read trace files, man, those are valuable individuals. And you can't throw every problem over the wall at the folks that really know how to work Wireshark on a day-to-day basis. You've got to be able to empower tier 3 engineers that maybe don't know packet detail as much, and especially the tier 2 engineers, right, that don't even get exposure to packets. Because packets really are a single source of truth for what's occurring within the environment. If you don't know what to do with them, they're not very valuable. And that's what we're trying to do with things like the user experience score. We're trying to refine all that unique, very specific calculations that an engineer would normally have to do and present it in such a way that it's highly consumable for a tier 2 analyst or maybe even a tier 1 operator in certain instances. And so if we drill into this, I'm just going to click on one of the conversations here, right? This is a pretty cool display. So user experience score, 2.4, quite bad, right? Problem domain isolation, network, client, server, and application. what are we finding to be at fault here? Well, certainly the network is yellow, right? There's some stuff to be talked about there, but the application is taking too long to respond to requests. Why? Because the server data delivery time and total data delivery time are about 4.5 seconds. That's a problem. If every request you make to the server is taking 4.5 seconds, that's going to be a long user wait time to completely fulfill their transaction, completely fulfill the page or the request that they've sent in, right? So this thing's back there churning for a really long time. The cool thing is that this display not only allows you to see the top level score, and it breaks down for you the problem domain that score is most attributable to, but on the right-hand side, you literally have the packets. These are the packets that are bouncing back and forth in this transaction. So if I want to turn off the packets that have to do with network delay, because let's just say it's not the network, and I want to turn off all the packets that have to do with the actual data fulfillment and that have no delay, I can literally just get a view of client and server delay, right? Here's my client request on the left. They do an HTTP GET. Server response on the right, that one took 2 milliseconds. Fantastic, right? Well, then I get a kind of a more robust query. You see that JDSU.com in there, right? Like I said, this is an actual issue from within our production environment, and you see the response time there, 3.6 milliseconds. Still not bad, right? But as I scroll down through this list, you can start to see some of these transactions start to take a very, very long time, right? And as you start getting into some of these transactions, there's transactions in here that took 4.5 seconds, transactions in here that took 10 seconds, right? And they average out to a data fulfillment time of about 4.5 seconds per query. And that's a serious problem, right?
So for collection,
Yes.
to get these packets, one of the traditional problems is, you can place collection in any number of places in your network. And so this is one of the, also interpretation is the idea is I'm seeing these transactions from here in the transaction flow. I mean, are there multiple collectors? Is that like, how does this work to try to get a broader picture rather than just, my client request came here? Because if I just drop it in let's say the data center,
Yep.
That's where I'm collecting packets.
Right.
I kind of miss all of the activity that happens between the client until it gets to that collection.
You do. You're absolutely right. So there's a couple different pieces of that, right? The first is, you're absolutely right. Most customers are deploying this inside of the data center. So they're seeing the east-west that's happening within the infrastructure. They're using packet brokers to feed the product most frequently, although some customers directly tap the traffic. And I would say it's about a 85-15. 85% of our traffic is getting fed to us from packet brokers, 15% off of taps and spans. The rest of the visibility can come from a multitude of different areas, right? You can leverage flow-based technology to get edge visibility, just to understand kind of counts and amounts and general statistics that are happening way out there on the edge. You can leverage synthetic test capabilities, which emulate real user experience, but actually, because you are the originator and you also have visibility in the destination, and start to tie that information together. And that's part of our long-term strategy and vision that I'm going to get into in just a couple of minutes.
Okay.
It's perfect. Just one quick thing I want to jump through here, and then I've got to turn it over to Ward, but I do want to walk you through a very common scenario, right, where you've got a user that's experiencing a problem. I've got this typed in here. So IP client 10.200.988. This is somebody who called in about a network performance problem or an application performance problem. When I click into the dashboard, I can see everything that's transpiring with that user. I can see all the different applications that they're using and so forth. I can drill into the different applications that they're leveraging. I can see the servers that they're most frequently communicating with, right? So I'm starting to kind of peel that onion and understand, where's the user start? What's their primary application? Which servers are they most frequently communicating with? And then to the point that was made earlier, right? If through this process I'm going, this is interesting, and clearly there's some sporadic issue that's happening here. I can see that this particular client is communicating to portal.petshop.com. They're trying a couple different browsers. That's kind of interesting. They're trying to use different browsers, thinking maybe I'll get a different experience. They're trying to just do basic GET requests, and their delays are not great, right? So this user is clearly experiencing some problems. Maybe the problem has nothing to do with the petshop.com front end. Maybe the issue has to do with their DNS resolution time or a back-end dependency like a SQL server or WebSphere or something like that that's in the service delivery chain. So what I can do is I can right-click and do an application dependency map. And this application dependency map literally maps out the client, highlighted in the blue box here, and everything they're communicating to, right? So here's their green connection to the 3 web servers that you just saw. Here's their yellow connection up to DNS, right? So they're actually experiencing some DNS delay that's above and beyond what they would normally experience. that may be why the user's perception is that the application is slow or the network is having a problem, but in reality, it has nothing to do with the HTTP application, the Apache server, the backend database. It has everything to do with their initial resolve time.
What's the duration on this? This is really very cool. But my concern here is like, okay, so you're trying to pinpoint a point in time.
Yep.
You're having problems at exactly at noon. What happens if you have a DNS issue at 11:55?
Yep.
But the application issue happens at noon.
Yeah.
Like there's obviously a time gap there that, these queries are going to happen just slightly off from each other.
Yep.
DNS query is going to come before I actually hit the IP address for the web server that I'm trying to hit.
Absolutely.
So you have to have some sort of give on either end to
Yep.
try to put together what the transaction was pulling all together. But if you give too much, you could be pulling in ancillary
Yep.
data that isn't part of the transaction that could actually lead you astray.
Yes, you're absolutely right. So it is time bounded to what you're saying, and we use quite a bit of analytics to try and understand exactly how much we should grab on either side. When the user passes in a time window of say 10 minutes, we actually try and time bound the transactions. And to your point, the software is smart enough to understand that, to your point, DNS is going to happen before the application transaction. So we're going to slide that window out a little bit. And we're actually going to look at the theme of communication to that DNS server and pinpoint exactly when we see interesting events occurring with the DNS server, and that's what gets represented on the graph. So it's not just simply we have a time boundary window and that's what we display. It's actually very refined. There's a lot of analytics behind the scene here.
So you're trying to identify similar calls that they all include these different types of services. So it's likely that
Exactly.
your call to this server is also going to include DNS. It's also going to include
Yep.
whatever else.
Yep, all those back, and then of course, what those servers are calling, right? So here's the HTTP servers. Where are they going back to? They're going back to a sys file server and 3 different TDS servers.
This is a fantastic
Where are they going?
view. This is really neat. Yeah.
And quick question related to
Please.
this. I noticed you typed in like the IP client ahead of the IP address. Do you
Yep.
have to do that, or you can just put in an IP address?
I was gonna
or a
ask that.
username?
You can just type in IP.
Address.
You can just type in
stick
IP. You can type in an application name. You can type in free string.
What do you gather the user's .1x credentials?
Yeah.
Like, can I type in S. Clements and
Yeah.
get all of my devices,
Yeah.
and then
It's a great
filter
question.
versus iPads versus MacBooks versus PCs?
It's a
And
great
then
question.
a weekly
Yep.
report to see what your client.
Exactly. I want to
Experiences.
show all of the CEO's devices.
Yes.
This is great. Yes. So not today.
Okay.
Right? Not today. You can't research the CIO yet, but a lot of cool things coming there. We'll talk about them.
Fantastic.
Guys, I apologize. I'm going to just, if we can hold just a couple questions, I just want to show you one quick thing, and then I got to get it over to Ward because I am running way over on time, and he is going to be angry with me. So I just want to show you one quick thing here, right? I'm going to do connection dynamics on that same conversation stream, right? And you can see that the extraction occurs, and I can run that extraction. I can view that information in the same type of a display that we looked at earlier. Here's the great thing, right? Is that if you do have a traditional Tier 3 engineer that goes, guys, this is awesome. Great visualizations, love the calcs, love the scores, but I got to send that to Cisco, or I've got to send it to another vendor, I've got to send it over to another team, right? At any point, you click the button, you save the trace file off. There's the trace file. That data just got extracted. And when you click on it, boom. There's your PCAP opened up in whatever your 3-pane decode of choice is. So you can always get down to the individual frames, the individual PCAP, and the trace.
Yes.
That is really slick.
Yeah. I was like, now, could you just add a button that just makes a TAC case? I mean,
So are you? So how, when you're storing
No, yeah.
When you're storing packets, do you slice the packets after the header, and you lose all the application data? Or
We don't slice the packets unless the customer asks us
Ask
to.
you to okay.
Most customers choose to retain the entire frames, and that's why some of these storage arrays go from 16 terabytes up to 1.2 petabytes.
Okay.
Most customers choose not to slice the frames because you lose so much of the context.
Quick question. IP client is usually too thin for me. I need to see like if one client's having a DNS issue, there's a good chance that the entire DNS servers is having an issue. So from a broad range, can I say this DNS server in my Atlanta data center is having an issue and point that out right away? Is that
Absolutely.
rather than trying to focus, zoom in really close on one client and then zoom out?
Yeah, so here's a perfect example of that, right? This is a site-based contextual view, right? So this is showing performance from site to site. And at any point, you can click on a pin. It'll show you this is our Eden Prairie office, right? I can go into the apps delay. I can see site to site delays. And if I click on any one of these, I can just drop down into that and say, show me application performance from site to site. And this will actually show you, there's your slowest applications, right? In this case, it's HTTP, but it could be DNS. So your dimensions could be the application itself, the server itself, application and server, client-based, site-based, right? It's very, very easy to kind of free-form it out. All right, so apologize for taking up so much time. Ward, you're up.
Before you run away. I'm sorry, Ward.
He hates me.
Yeah, on your search, you did IP client and then a name. I'm assuming there's different keywords. Are those documented somewhere? I'm thinking about the filters and searches inside of Wireshark, which can get really, really tedious.
Absolutely. Yep.
I want.
Flash.
Exactly. They're not exactly clear. So I mean.
So the hover over gives you access to a few of the most common ones. You can click on the link that'll take you to the more specific ones, right, the very nuanced ones.
How long is this list? Like,
There's like a couple dozen different very specific
that's
ones,
reasonable.
but you can also just say IP and don't give the context of client or server, and we'll show you that IP address from both as a server and as a consumer.
okay, thank you.
Yep.
All right, cool. This is the fun part about being the second presenter. My name is Ward Cobleigh. Are there any questions?
That's all we have.
So real quick, guys, we're going to do this in about 2 minutes. Observer Live is a cloud-based multi-tenant service that allows operation and support teams to ensure that users are able to access and efficiently utilize the services that they need to do their job. There's the one-sentence description. What's it look like? What are the pieces? What's it do? If your name, by the way, appears on this screen, you may or may not have won a valuable prize.
Robert Boardman, you're there. One violation.
One of the things...
And Ryan. And Ryan.
Just saying.
It's a light day for you, man.
Yeah, it is a light day for me.
Yeah.
One of the things, what we're doing right now is we're using some of our virtual agents that are deployed in the cloud to monitor websites that are associated with each of the delegates in the room here today. So, we may want to talk later, Ryan, Robert. Real quick, what are the pieces and parts of the thing? We talked about the fact that the application is multi-tenant, lives in the cloud. Agents are the things that are doing the work. Agents come in 4 different flavors. You have virtual agents that you can deploy on premises on an ESXi server, Oracle VirtualBox, whatever makes you happy. We have hardware agents, you've seen those. We have the cloud agents that live out in the Amazon AWS environment. We're expanding to Azure and Google Cloud. And then the 4th type of agent is an on-demand ad hoc troubleshooting agent where I can actually push a virtual agent out to a Windows only for today, PC. It will run a test that it's pre-configured to execute and report the results of that test back up to the cloud. So 4 types of agents: cloud, virtual, hardware, and troubleshooting. What do agents do? Agents run monitors. What are monitors? A monitor is a series of synthetic tests, consistent, repeatable, active test that's going to go out and talk to from the agent of your choice to the destination of your choice. Could be another agent, could be a service. Let's see what it looks like if it's a service, because we're only going to have time to look at one example here today. You notice, by the way, the screen is constantly reorienting itself. What we're trying to do is bring the things that we think require the most urgent attention up to the top. Basically, it's the things that are getting worse. The things that move down the list are things that are getting better. Based on the last test versus the current test, if it's improving, it moves down the list. If it's getting worse, it moves up the list. So I'm actually going to go look at something that we started monitoring yesterday just because I thought it was a really cool example. And it's not currently on the top of the list, so I'm going to go down and find it. It's an application you may be familiar with. It's called Workday. And so Workday at the moment is behaving itself quite well. We're glad to see that. We're testing Workday from 2 different places. We're testing it from a cloud agent in Toronto, and we're testing it from a cloud agent in Portland, and we're able to see that right now they're both doing quite nicely. However, if we look at our trend over the last 24 hours, we do see something here that could be concerning. Quickly, we're going to grab that chunk of time. We're going to go look at it. We see that we were over some preset thresholds of performance. Those can be set by the user, or after 28 days of data collection, they become dynamic. Right now, we see that we have thresholds exceeded. If I click on my breakout, I can see the components that make up the end user response time total. So we're saying, for instance, the total end user response time at this moment I have highlighted is 537 milliseconds. Of that, network is 468. So in this case, it looks like the network is taking up the majority of the time as opposed to server response, client response, or DNS resolution. We also noticed down here an interesting little stair step going on in our route analysis. So as we're testing the performance of this particular site or service, we're also looking at the route between the agent and the service itself. If I pin this moment in time when things are going well, I can see, if you've got really good eyes, that the destination, the Workday service, is being hosted on a server. It's an Amazon server in Montreal. The test originates in Toronto. So I'm going from Toronto to Montreal. Life is pretty good at this point, but look at this little stair step function that takes place. If I click here and I look at my destination, I'm now going from Toronto to Minneapolis. And so I'm going a bit farther to get where I want to go. Well, what happens here at the top of the ladder, if I click up here on this top plateau and I come down and look, I'm now going to Phoenix, Arizona. Yesterday, as we were watching this from the show floor, we were going to Western Australia from Toronto to get to a service that should be in Montreal, right? So we look at the story and we say, it's a network problem. Is it? The network's working just fine. It just so happens that you're using pieces of the network you shouldn't be using. I'm not going to blame the network, right? Every piece of this network is doing exactly what it should do. It's a speed of light issue, and it's a routing issue. But think about it. Now, if this were an application I owned and controlled, it was on premises, I own all this, and I can control these variables. But I subscribe to this as a service. What do? I call Workday and I say, hey, my users are experiencing degradation. You're routing me all over the world. What do? It just speaks to the challenge that we have as we move from an on-premises world to a cloud world, and the kind of information we want to be able to arm ourselves with so that we can have educated conversations with our service providers and help them get better at what they do. And with that, I think I'm like officially out of time, am I not? I got 1:38 left, Charles.
Beautiful. Thanks.
Enjoy.
So real quick question. One of the things that I've got to say I'm really impressed with is how responsive the app is. Yeah. You're pulling a whole lot of data real fast. Is this what a normal customer is going to see? I mean,
yes. So what Ward's showing you here is actually the production observerlive.com. So if a customer goes out and signs up for observerlive.com, they're going to use the exact same environment that Ward's using here. In fact, it's actually a little bit more, because when we do our demo systems, we restrict some of the microservices. In a customer environment, they can spin up dynamically as needed. Okay. So this is truly a hyperscale application that's hosted in the cloud and is designed for major customer loads.
Okay. And what about the first demonstration we saw?
So the first demonstration we saw is Observer Apex. That's on-prem self-managed. So most customers have half a dozen people accessing it simultaneously, and for the most part, they experience the performance that you just saw there. That environment that I was running was actually being fed by 3 different Gigastore appliances, which is pretty typical for most customers.